Hey there, thanks for tuning in to this video. It is Mrs. J, and I'm here to look at Centroids in case you were out and you missed it, or you need a refresher because they're tricky. So Centroids for Principles class, 10th grade. So take a look with me on how to do a problem. Okay, so how to get there. Go to log into My Project Lead the Way, go to your course, Principles of Engineering. You'll get the main page. Come over to the side here. It pops up the search bar and just type in Centroids. Once you see that, let me get this in the frame. Once you see that, you can click on the one that pops up. So this one right here, regular Centroids, the appendix, not the lesson. It'll be highlighted until you X this over here, X that over there, and there we go. So Centroids, we're looking for the center of an object to see how it holds up when you put some weight on it, you put some force on it. So it looks all flat and 2D here, but we're going to look at like full structures later on. So you have a square, the centroid of it is right in the center, axis of symmetry. You have a circle, also axis of symmetry. And then they give you the formulas, how to locate the centroid of a rectangle. You have to use this over here from the x-axis right here to locate this. You need to use the base divided in half. So the base is x inches divided by 2, it's half of that. That's the length right here. And the same thing for the y, going vertical. You take the height, cut it in half using this formula, height divided by 2, and that's how you locate both of them, and you'll end up right here. So you're getting this measurement, and you're right here. So pretty easy, and we're trying to say how far away it is from each edge to the centroid. Right triangle, very similar, except we're cutting it into thirds. Just be careful with your placement on these. Most people tend to move this up a little higher because they're still thinking about rectangles, but it's a third. So cut this into 3 equal segments, and then you've got y. Same with this. Figure out the base length, divide it by 3, and you've got x, and your centroid's right where they meet. Semicircle is how we break down a circle if we only have partial. Has a little bit trickier formula, but still simple. The x is always going to be your radius, not your diameter, but your radius. Remember, your radius is any segment along the line, so any point along this line to the center would be the radius. So we're going to measure it, put it right there. And then for the y side, it used this formula, 4 times this length divided by 3 times pi. Watch how you place that in your calculator. Be careful with that. They give you a little, if you check on your work, they give you an example. I would use this to make sure you're using your calculator correctly. If you put it all in at once, you're going to get the wrong answer. Play with it once or twice, come up with exactly this answer, and you know how to use your calculator. Okay, and the reason we have those simple ones is that if we get a shape that's complex, and we want to break that down, then we can use those simple ones. We can use a rectangle formula right here. We can use a triangle formula right here. We can use a square formula right here. Let me just scroll down a little bit and show you why we're doing this. Okay, so this is actually what we're trying to look at. If you take on one of these beams, think of them as beams that are like going in your walls. They're going from the floor to the ceiling. They're going across the floor, across the ceiling, and they're giving you support. Right? So this is what you end up building, steel, whatever they're being made out of, right? Or something that's enforced. And what we're looking at is taking the side of it. So see this, there's kind of like a little letter I in right here. You look at that and look at this. That's what we're looking at. If we were to cut it down and just look at it flat, what do we got now? Okay, so let's break down this shape. We did do this in class. If you were out, make sure you're taking a look at this, or if you just didn't get it in class, that's fine. This is tricky. So we have this weird shape. We know that it's 6 inches overall height, 6 inches overall base, and then they gave you a little bit what happens if you cut it in half, which we understand. We're going to use the additive method. There's additive and subtractive. You're going to see subtractive in your classwork that should be done already. So I'm just going to scroll down here. We took that same shape. We're going to go through here. We took that same shape. We broke it into 3 sections: a rectangle, a triangle, and a square. See if I can make this full screen. There we go. Okay, again, if you go to Project Lead the Way, you can walk yourself right through this. Easy peasy. We know that it's 6 inches overall base, 6 inches overall height. We're using engineering dimensions here to take a look at it. So how we're going to find the centroid? If it were a regular square, if this was closed right here and right here, then you simply have the axis of symmetry and your centroid's right here. But you're going to find that because this space is missing, this cutout triangle right here, that your centroid's actually going to be placed over here. It seems very trivial and very small, but picture hundreds of these holding up a building all placed in the wrong spot. The buildings can collapse, and we're seeing that. We're seeing some buildings collapse. That's just an engineering design flaw you have to be careful with. So right here is where your centroid's going to be. You're going to have some space right here to move that load over this way because you don't have full support in that corner. All right, so let's go. If you want to do this yourself, you just click on the buttons and it scrolls through. So the first thing you have to do is follow the steps. If you scroll back up here, they give you all the steps, exactly what you have to do, exactly what you need to do in each step. If you do all of those, you'll get your centroid correct in order. So you find the area of each shape. Area of a rectangle, remind yourself width times height. Area of a triangle, that's shape number 2, half times base times height, and area of shape number 3, that's side squared, or people like to say length times width, but they're the same, so side squared, same thing, right? When you're doing this, remember to work as an engineer, do your notation properly as an engineer, don't get lazy, that's how mistakes are made, because you're going to find this is only less than an inch away from where it should be, and yet if you had 100 of these in a building, the building could collapse. So that's on you. You can do this. So you're going to find that the area of shape number 1 is 18 inches squared. I suggest you throw this in your calculator, remind yourself how to do it on your own, because it's been a while, right? Area of shape 2 is going to be 4.5 inches squared. And then area of shape 3 is 9 inches squared. So remember, you have 3 inches times 3 inches. 3 times 3 is 9, but inches times inches is inches squared. So have that proper, inches squared. On the EOC, you might just get one of these questions broken down. Okay, so what we know is that if you find the centroid for each shape, and this is a step in the process of finding the final centroid, is that for the rectangle, it's in the axis of symmetry, dead center. For the triangle, it is 1/3 the base, 1/3 the height, so it's not exactly center, it's a little here, right? And then for the square, it's right in the center axis of symmetry. So remind yourself all of these things. Don't just rush through this, read through this. See how this is away a little bit to the right of that. They're not lined up perfectly. We're going to find a happy medium right over here. So taking a closer look, we know our area of this rectangle. We know the area of the triangle. We know the area of the square. Easy. We also know where the centroid should be for each. Symmetry, 1/3, symmetry. Now we're going to say, well, how far away is each one of those centroids from the X and Y axis on the original shape? So here we placed our centroid. We know that it's 1.5 inches because it's halfway across from the Y axis. But going down to the x-axis, it's 3 inches. Remember, because the height was 6 inches. So 1.5 and 3. That one's nice and easy. Let's come over to shape number 2. We know that we placed it right here. It's an inch away from the triangle, but we're not looking at just the triangle. We're looking at the whole shape. So it's an inch here and 3 inches here. So it's 4 inches total. That's the tricky one. And then the same thing going in this direction toward, it's the y-axis going towards the x. And it is 1 inch right here, plus 3 inches this way. So you just have to pay attention to that and see where it came from. So 4 inches total. On the third one, it's right in the center. We know that it was 1.5 inches from the square that we were looking at, but it's another 3 inches here to the reference axis. So 3 plus 1.5, 4.5 inches. And then down here, just 1.5. So you see that 1.5 here, and then 3. Okay. Next one is we're going to look at the area. So we found the area already. A few steps back, we found that shape number 1 was a rectangle. It was 18 inches squared. We also found that its reference, so let's go back and look. Shape number 1, 1.5. Shape number 1, 1.5. The whole area was 18 inches squared. This x, going in the x direction is 1.5 inches. So let's go back. 18 times 1.5. So you have to line up this table. Don't skip making the table, and then multiply across. 18 inches squared times 1.5 gives you 27 inches cubed. Another place to be careful. Inches squared times inches is inches cubed. You add the exponents. And then for number 2, we're doing all in the x direction. So it's just shape number 2, 4.5 inches squared and 4 inches. Let's look and see where that came from. Shape number 2, it was 4.5 inches squared because we did the area earlier, and times 4 inches. And then shape number 3, it's going to be whatever the area was times 4.5 inches. So let's go back. So these two multiply across, and then you get your answer in cubed. So be careful not to skip these part. Practice writing them down so you can see where they came from. It's easy to agree with the video. It takes more work to write it down and take a look where it came from. Then you do the same thing from the y-axis. So I'm going to go back. We do the area, and we multiply it by the y-axis. Shape number 2, we do the area, we multiply it by the y-axis. So it's going up and down. In number 3, we take the area, multiply it by this. And you'll see that here. 18 times 3, 4.5 times 4, 9 times 1.5. When you're writing it in your notebook or on something to turn in a packet, you need to make sure that you're doing proper engineering notation. Inches squared times inches, inches cubed for each one. So that was easy, right? So now we have the area times, we call this x bar or y bar, and that's our area. That's where our centroid is located. Now you want to take the sum and put it all together. So got a little tricky there. I'm going to go back. It says the sum of the area times x bar, or the sum of the area times y bar. So I'm going to go back. We already know the area, right? I'm going to add them all together. We got it all here. Let me just make sure I have that right. Yeah, 27, 18, 40, 54, 18, 35. So let's go back. So we're going to add all these together. Add them up. Get an answer. Add them up. 54 plus 18 plus 13.5. When you're adding exponents, they don't change. So your answer is going to be, you're going to each one separately. These 3 get an answer. These 3 get an answer. So separately, let's look at it again. 27, 18, 40.5. It gives you 85.5 inches cubed. 54, 18, 13.5, 85.5 inches cubed. That doesn't always happen. This is Project Lead the Way being nice to you. Enjoy it. They're usually different. Okay, next one. So we got our areas. We got that far. We already know the areas of each individual shape from earlier. We had the rectangle, the triangle, the square, and they had their inches squared. And we're going to add those together because we're going to use them in a final formula. So 18 plus 4.5 plus 9. And they're all inches squared, so 31.5 inches squared would be your final answer. Now we're going to put those two things in a formula. So I'm going to go back one. We're going to take this right here and this right here. We're also going to take this one, all the areas. I'm going to put them in a final formula. Super cake, easy. So we have the area of everything times x bar. We have the area of everything times the y bar. We got 85.5 for each inches cubed. We're going to divide each one of those by the area of each individual shape. So normally these would be different. We're going to do the repetition even though it's the same thing so that we show where we get the number for the x bar, where we get the number for the y bar. And when we solve this, this is your formula for each. The sum of the area of all of it times the x bar of all of it divided by the area of each individual one is going to give you the x bar centroid location. And you're going to find that they're 2.71 in each direction and not 3. The height was 6, the base was 6, so if it was a square, the centroid would be 3 and 3. But it's 2.71, that little tiny bit of difference, 0.29 difference. is all you needed to keep your building secure. So thanks for watching. Have a great day and happy math.